Welcome to part 2 in our video series covering the just-in-time session for 3rd grade. In this section, we're going to be going over modules 3 and 4, which will be taught in the second 9 weeks. We're going to be highlighting the priority standards, talking about some data directly related to the priority standards, and highlighting some instructional strategies that can be used to teach this important content. So again, for 3rd grade, we have 2 modules we're going to cover, modules 3 and 4. 3 is about multiplication and division with units of 0, 1, 6 through 9, and multiples of 10. So this is the second time that we are going back and revisiting the concept of multiplication, but now we're extending it to those harder factors and eventually 2-digit by 1-digit. In just a little bit in the video, we will come back and discuss module 4, which is multiplication and area. One resource I wanted to highlight for you from the Great Minds website is the module overview videos. If there's one for every single module, if you go to the Great Minds app on ClassLink, go to the bar and select your grade level. Over to the top are going to be some tabs. You're going to select the tab for the module that you're wanting to preview. Under that will be several things listed. The first one should be module resources. Once you open that up, you'll find the one that says grade 3 module, whatever, preview video. They are short. They're only 4 or 5 minutes long, but they are fantastic. I would be pulling these up during PLCs when we're starting a new module to learn about what the important learning that's going to take place during the module. Each module overview begins with previous learning. What skills should my students be coming to me with that are directly related to the content I'm about to teach? In this case, it's going to revisit the learning that occurred in Module 1, or it might go back and revisit prior grade level learning that vertically aligns to what we're going to be talking about in the module. Then it goes through each topic and gives you visual examples and strategies, previewing what's going to happen in each topic. And at the end of the video, it tells you vertically, well, where is this learning going? Is there a later module within my grade level that this is going to connect to? Or is this learning going to connect to future grade levels? So it explains that vertical connection. It's a really, really great resource. Okay, so this was an activity that we did in the live session. I'm not going to do this activity with you. I'm just going to point out that if you looked in the module overview at all of the topics, there are topics A through G in this module, and you could read the blurb about each topic and find some connections. For example, topic B to topic D talk about using properties of multiplication and division to solve times 6 and times 7. We then extend that to topic D, where we're going to use properties of multiplication to solve times 8. You can see that topic A is connected to topic G because the focus of those two topics are word problems and how to apply the multiplication. And so just a quick little activity, glancing and making connections between the topics. All right, the priority TEKS for Module 3 are listed on the screen above. We are really going to heavily focus on 3-4K, solving one-step, two-step problems involving multiplication and division within 100, using strategies based on objects, pictorial models, including arrays, area models, and equal groups, properties of operations, or recall of facts. And the other standard we're going to spend a lot of time on is 3-5B, represent and solve 1- and 2-step multiplication and division problems within 100, using arrays, strip diagrams, and equations. In order for us to get that vertical look about where my students are coming from and then where are they going to go, we're going to dig back into 2nd grade and look at the TEKS that directly align to our priority standards. In 2nd grade, students learned through 2-6A and 2-6B how to model, create, and describe contextual multiplication situations and division situations in which equivalent sets of concrete objects are either joined, in the case of multiplication, or they're separated into equivalent sets in the case of division. In 2nd grade, students also learn to represent and solve addition and subtraction word problems where the unknowns may be any of the terms in the problem. We already went through the 3rd grade standard, so let's look vertically ahead at where our learning is going to take our students in fourth grade. These two standards are very heavy priority standards in fourth grade. They're going to take what they learn in third grade and in 4.4-H, solve with fluency 1- and 2-step problems involving multiplication and division, including interpreting remainders. And 4.5-A, represent multi-step problems involving the 4 operations with whole numbers using strip diagrams and equations with a letter standing for the unknown quantity. Now we're going to look at some third grade data from the past that is aligned to the priority TEKS that we're going to be focusing on. We're going to start with 3.4-K. The STAR test last year, 3.4-K, 38.58% of students mastered that TEK on the STAR test. So let's look at those questions. That's a pretty low average. Let's see what happened. There were 2 questions in 2025 that were on that standard. This is the first one. Amy, Carl, and Liz equally shared 60 building blocks. Amy divides her share of the building blocks into 4 equal piles. How many building blocks are in each of Amy's piles? So as you can see, only 32% of students got this one correct. And it's because it's a 2-step problem. First, I had to take the 60 blocks and divide it equally among the 3 friends. That gave them 20 each. And then they had to take the 20 blocks, and Amy is dividing hers into 4 equal piles. So then they had to divide again. The other 3.4-K problem in this year was this one. 44.6% of students got this correct, so it was a little bit better. Frank puts 90 pictures in a book. He puts 6 pictures on each page. How many pages does Frank put the pictures on? Enter your answer in the space provided. So it's only a 1-step problem, but we're starting with 90 and dividing it by 6. So in the module where we're taking number bonds and decomposing numbers into friendly numbers, that's going to be a very strong strategy when we're having to divide larger numbers like this. Plus, it was a text entry, so it takes the guessing part away. We don't have 4 choices to choose from. All right, let's look at 3.4-K on STAR in 2024. It wasn't too bad. But let's look at the CBA from last year. We're talking about not the early adopters that use the Eureka curriculum, but from the old curriculum, Unit 2, Part B, only 29% of students got this question correct. So let's take a look and try to figure out why that was so hard. This is the CBA question from that year. Miss Brighton is planning a holiday party for her class. Each student will get 2 sugar cookies to decorate. There are 20 students in her class, and there are 5 sugar cookies in each package sold. How many packages of sugar cookies will she need to buy? So for this one, only 29% of the kids got it correct, and you guessed right. It's because it's a multi-step problem. So I'm having to multiply the 20 students in each class, each get 2 cookies to get the total number of cookies. And then I have to take the total number of cookies and put 5 cookies in each package. That on top of the fact that it was text entry, so we didn't have any multiple choice to guess from, made this pretty tough. All right, let's look at 3.5-B. 3.5-B on the STAR test last year, only 55% of the students got it correct. So let's take a look at what those questions looked like. There are 12 students in a class. Half of the students play an instrument. There are an equal number of students who play the guitar, piano, and violin. Which set of equations can be used to find how many students play the guitar? So you can see by the fact that it's a set of equations that this is a 2-step problem. I have to think about what is the first step, what's happening first, how do I represent it, and then what is happening in the second step and how do I represent it? 55 students got the correct answer of D, so multi-step, 2-step. And what about STAR in 2024? Only 55% of the kids got it correct again. A sports complex has 4 basketball courts. This is the one from, or very similar to the one from ongoing review that we talked about earlier. So again, having to represent a multi-step problem. Since it was drag and drop, it could have been up to 2 points. 16% of the students got both of them wrong. 38% of the students got one of the blanks correct, and only 45% of the students got both blanks correct. The other question that year was the same comparison problem from ongoing review. So this time, instead of it being a set of equations, it's one equation, but it's still two steps. So having to identify, what am I doing first? How do I represent it? What am I doing second? How do I represent it? So this one was 40% correct, and the answer was C. And then finally, I'm not going to go over these for 3-5E, recognizing relationships in a table. We do fairly well on that, usually on STAR and our CBAs, which is why I'm not going to take the time and go over that right now. But for some reason, those TTAP questions were tough. I don't have access to what those look like, but just to keep that in the back of your mind. So what do you notice about what students are struggling with? Well, yeah, they're struggling because they're multi-step problems. They have a really difficult time with two-step problems. So we're going to take some time and work through some strategies on how can we teach our kids to analyze and think through multi-step problems. Here's the first problem. Joe has $173 in the bank. He earns the same amount of money each week for 7 weeks and puts this money in the bank. Now Joe has $208 in the bank. How much money does Joe earn each week? A strategy that I try to work with my teachers on, and when I was a teacher, I would work with my students on, was identifying what's the goal? What is going to get me the correct answer? I need to know, how much money does Joe earn each week? Then I have to kind of back up and look at the structure of the problem and what's happening in this problem. Let's represent what we know. Well, we know that he is starting with $173 in the bank. That amount changes because he's earning some money each week for 7 weeks and putting it in there. So I'm starting with 173, I'm adding some to it, and then I have $208 at the end. So I can represent that like this. So I have the total is the total amount of money in the bank at the end of the problem, and it's made up of two parts. The part is the money that he started with, and then the second part is the money that he earns and puts in the bank. Those two pieces together should give me the total at the end. Okay, so let's go fill in the numbers. So we do know the total. He ends up with $208 at the end. We do know how much he started with, which is the $173. What we don't know is how much he puts in the bank. So looking at this problem, what could I do to solve for the unknown? Well, I could take my total of $208, I could subtract the $173, and that leaves this part being $35. But does it answer my question? Is $35 how much money Joe earns each week? No, that's the total amount that he earns. So I have another step I need to do. So we're going to look at that second step. For that second step, we're going to represent what do we know. So now we know that he had $208 in the bank at the end. He started with 173. We know that this part over here is a total of 35, but that's over the course of 7 weeks. So I'm going to take that part and separate it into 7 pieces. And that's the part I'm going to focus on. How can we find the unknown? So I'm focused on just this part. I see a total of 35. And I see that it's being split into 7 equal groups. That's 35 divided by 7, which is 5. He earns $5 each week. All right, let's try another one using that same strategy. Rose has 9 pieces of yarn that are each 6 centimeters long. Sasha gives Rose a piece of yarn. Now Rose has a total of 81 centimeters of yarn. What is the length of yarn that Sasha gives Rose? So we start with, what's the goal? What am I trying to find? I'm trying to find the length of yarn Sasha gives Rose. So then I kind of back out and I think about the problem. I'm starting with 9 pieces of yarn that are 6 centimeters long each. So I have 9 pieces of yarn in my hand. They're each 6 centimeters long. Sasha comes and gives me another piece of yarn. So that amount is changing. It's getting bigger. She gives me another piece of yarn. And at the end of the problem, I have a total of 81 centimeters of yarn. I can represent that. If I back up a little bit and think about the structure of the problem, I can represent that. So I know that I have the total amount of yarn that Rose has at the end, and it's made up of 2 parts. It's made up of the yarn that Rose starts with, and it's made up of the piece of yarn that Sasha gave. So the yarn that Rose has plus the piece of yarn Sasha gave her together make the total. Now let's fill in the numbers we know. We know that she had 81 at the end of the problem. We know that the part that is what the yarn that Rose started with should be 9 pieces, and each piece is 6 centimeters long. So I can do 9 groups of 6. And that makes the unknown the amount that Sasha gave. That's the question. That's what we're looking for. So looking at my strip diagram, I can immediately see, well, I can do 9 groups of 6. I can figure out how much yarn Rose has. If I had the total and I had this part, I could subtract them, and that would give me the missing part, the yarn length that Sasha gave. So we're going to try to take the total. We're going to subtract the part that Rose gave us, the blue part, and we should be left with the yellow part, the yarn that Sasha gave. Now let's fill in the numbers we know. Do we know the total? Yes, we do. It's 81. Do we know the part that Rose had? Well, kind of. We don't know the number yet, but we do know that it's 9 groups of 6. So I can replace that with 9 times 6. And I know that 9 times 6 is 54. And then we're left with the yarn that Sasha gave. So I can subtract my total minus the part I know, 81 minus 54, and that gives me 27. So Sasha gave Rose a piece of yarn that's 27 centimeters long. That's the end of our second video. Our third video is going to highlight the new resource we have to help our students practice this thinking.